So, thank you all for joining and welcome to today's webinar. Uh, Before continuing, I would just like to ask if you hear me well. If yes, just could you write that into chat? Perfect. So, firstly, let me introduce myself quickly. My name is Amogh. I'm based in Frankfurt, Germany. I'm working with Hager as product manager with global responsibility of surge protection range. And I'm here today to talk about surge protection devices and how they protect and keep people and property safe. Before moving further, let's talk about some ground rules for today. During the webinar, your microphone is muted and cameras are off, so we can't hear you and we cannot see you during the presentation. Nevertheless, questions can be asked in the chat and will be answered during or at the end of the webinar. If you need help with the sound system or anything else, please report it in the chat. If there is no sound, please check your settings, or the simplest way is to exit the webinar and re-enter it again. So at the end, there is going to be a poll with a giveaway. And after the webinar, a follow-up email will be sent out with a schedule on the upcoming webinars. You can also replay the webinar on YouTube if needed. One more disclaimer for today. Due to unavoidable circumstances, our colleague Arun, with a sales background in your region, cannot be with us today. I will just concentrate on technical and the global view of the SPDs. And the questions regarding the local habits, local installations will be answered in the near future by Arun. So let's look at the agenda for today. We will start with situations and basics of overvoltages first. Then we will go on into the types of SPDs and how to connect them. If the time permits, we can also look into the Hager product portfolio. Maybe now for better network connection, I would now turn off my camera. So let's go on. The situation. Recent data globally outlines the huge annual damages that surges are causing. For example, in France alone, 2 million strikes were recorded annually, causing deaths, number of fires, and many more damages, including electric meters. The damages were up to millions of euros, and that's just the beginning. Additionally, the climate change always is playing a role and affecting the safety of people and buildings. Therefore, SPDs are becoming mandatory in certain countries, for example, Germany, France, Greece, etc. The need and the demand for safe surge protection is increasing. So, why do I need surge protection? What do these small devices do? Well, they protect electrical installations and connected devices from the damage. They serve as preventive fire protection. They assure the availability of the system, and they increase the personal protection. So what is Hager's motivation between this? So there are, as you saw, many number of great reasons why we should have SPDs or the surge protection devices. But when it comes to protection of human life, we all will agree that's our priority. Now let's take a quick deep dive to understand the overvoltages and its causes. In simple words, the overvoltage is that voltage that exceeds the operating voltage of any end device or a system. Overvoltages in the electrical systems can be different. They can last from microseconds to hours or days and have amplitudes ranging from millivolts to thousands of volts. So what makes transient surges so dangerous? And how do they differentiate themselves from the normal overvoltage? The clear answer is sudden increase in amplitude of the surge and its short time period. The aim of the SPDs is to reducing the incoming surge to a level which is accepted for the end device. Now, let's go on and see the causes of such transient overvoltages and surges. The first cause, as we all know, lightning strikes. They have the greatest destruction power in them. They are of short duration and high amplitudes. They might have direct or indirect impacts. I would then go on with the second cause, electrostatic discharges. This can be caused by galvanic, inductive, or capacitive coupling due to the magnetic and electrical fields when exposed to conductive parts. They are not as hazardous as lightning, but they also bring with them the small surges. The third cause of transients, switching operations. They can lead to induced transient surges within the nearby networks. What does that mean in the practical world? For example, tripping of a fuse link or switching a big consumer can cause a transient overvoltage too. So what is all getting affected with these surges, and what all will face severe damages? Well, all the electrical appliances in your home, in your office, or public buildings, the cell towers, the IT servers, the specialized buildings using sensitive electronics or labs, and the antennas. Everything will face damages. But the worst thing is, insurances often only covers property damages, but not the downtime. And this is very important to know. In some cases, natural disasters like lightning, floods, earthquakes, etc. are not covered too. So the impact and the consequences can be extremely expensive. Now let's look at the type of the SPDs and the type of surge waves to protect against these transient overvoltages. The surge wave are standardized and classified by the IEC norm. There are three kinds of surge waves, as you can see on this slide. The type 1 wave, the 10-350 microseconds, type 2 wave, which is a 8/20 microsecond wave, and a type 3, 1.2/50 microsecond wave. Let's go a little bit deeper and understand what are these numbers: 10-350, 8/20, 1.2 to 50. Now let's maybe, for example, let's concentrate on the type 2 wave. So just understand this 8-20 is time periods. Both the numbers are time periods measured in microseconds. If you can see, the first time period T1 is 8 microsecond. It is the time that is needed for the wave to reach its 90% of the capacity. And T2, that's the second value, is the time which is required for the wave to descend down to 50% of its original value. So this current or voltage waves will be produced in the labs to simulate lightning strikes and overvoltages for the type testing and approvals. All the parameters of the tests are clearly defined into the standards of the SPDs. In order to answer to these three different kinds of waves, we have three different kinds of SPDs. So type 1, for the type 1 wave, we have type 1 SPD, which is recommended for the commercial and industrial buildings with lightning rods or overhead lines. This is the type of SPD which protects you against the type 1 wave. Let's move on to type 2 SPDs, which tackle and divert the type 2 surge wave. which is a 8/20 microsecond current wave to the ground, and they reduce the remaining over voltage to less than 1500 volts. Now let's see the compact and the smallest devices, type 3. They are recommended for sensitive loads in addition to the type 2 SPDs. And they are usually installed in combination of type 2 SPDs in the vicinity of the end device. All Hager SPDs are compliant to the Lightning Protection Standard IEC 62305 and the SPD Product Standard IEC 61643-11. With the Hager's surge protection range, all normative requirements can be implemented simply and safely. The range includes combined SPDs type 1, 2, or 3, which cover majority of the applications, as well as SPDs for protection of multimedia, telephone lines, and communication devices. In doing so, we follow the motto at Hager, less is more. Therefore, we have reduced the number of variants and made the portfolio sleek. So fewer products now cover even more applications. At Hager, surge protection devices of type 1 are available with the spark gap technology. Now let's look at where these SPDs are installed. For example, type 1 SPD is installed at the service entrance, means in the main distribution board or in the sub-main distribution board. These devices act as primary protection. Now let's look at type 2 SPDs. These SPDs are installed downstream of type 1, and they act as second source of protection. They are usually installed at the distribution level, for example, in the sub-main distribution boards or even in the final distribution boards. Now, type 3 surge protection devices are used for end device protection as they face 1.2/50 microsecond current wave. The ideal and the best protection is guaranteed when you install all the 3 SPDs in cascade. Now, one can classify the SPDs in the 2 kinds of protections. Most commonly asked question in the SPD world is, which SPDs should we install? Which type? And where? Now, we have developed a simple and easy to understand flowchart to make your selection very easy. As you see, the selection guide, the first is divided into 2 parts. The first part talks about the main distribution board, and the second part talks about the sub-main distribution board. For example, in your region in the Middle East, let's talk about some example which is commonly known to us, and let's see if we are able to come to a conclusion and select a type of device. For example, let's consider the very well-known Burj Khalifa. As we all know, it has an external lightning protection. That means they have external lightning rods installed on the building. So let's go and try to answer some of the questions in the flowchart and try to find the right kind of SPD. First, external lightning protection system available or overhead power supply available. So as we said, for Burj Khalifa, yes, external lightning protection is available. That means we follow the logic yes, and we arrive at a type 1 SPD in the main distribution board. Now let's go ahead and answer the next question. Line length to the sub-distribution board or end device is greater than 10 meters. So as we know, Burj Khalifa, it's a huge monument, I would call it. And it will have a sub-distribution board or the sub-distribution boards, which are obviously more than 10 meters at length. So I say yes, and subdistribution is available. Yes, it is. Then I land at the type 2 SPD. That means my submain distribution board will get a type 2 SPD. Now I go on and answer, okay, line length to end device is greater than 10 meters. Yes or no? I wouldn't go now into more details because I personally do not know how the Burj Khalifa and the electrical installation is inside the building, because normally the submain distribution board is on each floor. And if the main end device is greater than 10 meters away, then I choose a type 3. If not, I leave it like that. So one can see how you can choose easily the SPD the right way according to your habits and installation. Now, let's go on and find out how to connect those SPDs. The SPDs are connected between line and the ground. The type of the grid network also plays a role in the choice of the SPD. For example, TNC network or a TNS network or a TT network. This will have an effect on your choice. So let's concentrate on the three-phase systems, which are commonly used. These diagrams on the screen show you how three-phase SPDs are connected internally. So there are two types of schemes available on the market: CT1 scheme and CT2 scheme. CT2 provides more protection than the CT1. For the obvious reason, as you can see, the CT1 connection always protects with a one SPD component between the line and PE, wherein the CT2 connection always has one SPD connection between line and neutral and two SPD components between line and PE. All the Hager devices between the L and PE path are protected twice. That means we follow the CT2 connection scheme. Now let's come to SPD's connections externally. How the SPDs are connected externally. So there are two ways to connect them: parallel way, which is also called as branch wiring, or the series way, which is also called as V wiring. So the cables to the SPD must be as short as possible. According to the norm, the length of the cable must not exceed 0.5 meters. This means the total number of length of the cable counts from the L to the SPD to the ground. The total length should not exceed 0.5 meters. Now, let's quickly have a look at the Hager's offer of the SPDs. So these combined type 1 plus 2 SPDs are designed for high performances with a spark gap technology. It's a pluggable solution. The individual cartridges can be replaced on end of life. You clearly see a red indicator which signals that the cartridge is end of life. Then one can directly approach the device and switch the cartridge. These devices do not need backup protection until 315 amperes. It can be used for all types of TN networks. That means TNC, TNS, or TT. This kind of devices come with a remote contact to send out alarm in case of failure. So your electrician need not always go to the cabinet and he has to look at the device himself. Now let's jump to our type 2 SPDs. Hager offers wide range of type 2 SPDs for each applications from 1 pole to 4 poles. It has ratings from 8 kA to 100 kA. Those devices are VDE, NF, and KMA certified. And these small devices also come with an optional remote contact. Now let's have a look at type 3 SPDs. They are compact and installed near the end device. These SPDs also come with a remote contact, and these can be used in AC or DC applications. Moreover, we have SPDs dedicated to photovoltaic applications, which are KEMA certified and have a special mechanical locking system, what you see the red lock on the picture. These devices are also pluggable. So just to summarize in one slide, Hager SPDs offer a simple cartridge replacement. It's an IEC compliant range. It has a less complexity and more ability. It's easy to choose. It's safe and easy to install. And it has proven functionalities. Now, we have come to the end of the presentation. So we have enough time for the question and answer session. But before that, it's time for a poll. Now, the question for the poll will pop up on the screen. Let's wait 2 minutes for the answers. It's great. I see people answering. So let's wait another 2 minutes. People are still answering. It's good. Almost 60% of audience has answered. It's great. Now, in the couple of minutes, another survey question for our feedback would pop up on your screen. There we go. Your feedback is really appreciated. Okay, then let's arrive at the question and answer sessions. Then I would first of all check the chat in order to see if there are any questions. So I see there are 3 questions in the chat. The first one is, shall we connect type 3 SPD after the main circuit breaker in the FTP or recommended on the circuit branch circuit breaker? So it's a good question. I would try to answer it briefly. So the type 3 SPDs is, as you must have seen in the slides, always comes after type 1 or a type 2 SPD. And every SPD needs a backup protection because SPD is not, it doesn't work as a circuit breaker. So it needs to just shut down from the grid. It needs always a backup protection. So the answer is, it is always recommended to install it after the circuit breaker. The next question, question 1, sorry, I forgot. I will read out the question loud. You have mentioned that Hager SPDs are compatible with the type TT system. So can we connect an SPD to an electrical system without earthing wire? So unfortunately not, because every SPD needs a ground connection, because this is how the SPDs will take the surge to the ground. Now let's have a look at next question. Type 3, is it a current wave or a voltage wave? Yeah, so type 3 is a voltage wave. So type 1 and 2 are current waves. Let's go on with the next question in the chat. What about Hager DC SPDs? Yes, Hager has DC SPDs. As you must have seen, the photovoltaic SPD, what we offer, it is installed on the DC side of the photovoltaics. And it prevents the inverter as the end device from the DC current. Now, the next question is coming from, okay, which type of SPD can be used with low current systems? So it doesn't matter if it's a low current application or a high current application. First of all, what we need to understand is if we have external lightning rods installed on the building or not, or do we have an overhead line connection? If the answer is no, as you must have seen in the flow chart, you can directly install a type 2. And then in order to protect your end device, you have to see if your end device is between 10 meters from the type 2, that's the thumb rule. And then you have to install a type 3 or not. Now, the next question, whether all the SPDs from Hager is certified by KEMA. The answer is yes. So there are also certain SPDs which are country specific. For example, Germany. So those SPDs are KEMA certified plus VDE certified. Now, going on to the next question. Is there any charts or table for choosing the right SPD? Yes, there is. Those you can later on replay the webinar on the YouTube. There you will see a flow chart which gives you an answer to which SPDs should be chosen. And if it is not clear and you have still more questions, kindly contact your local sales colleague at Hager. Okay, now let's see the next question. Why do you suggest fuses or breaker for protection before the SPD? All right. The SPD itself, as you must have heard me talking before, is they are not circuit breakers. Their function is to take the surge through them and put them to the ground. Now, after the surge is I would say diverted to the ground, this path of the SPD acts like a short circuit for the grid, and it will send a short circuit. Then we will have a short circuit current flowing through the grid for some milli or microseconds. And in order to, I would say, separate the SPD from the grid in this type of, I would say, installation, we need circuit breakers. So the circuit breaker or any breaker is there to protect the SPD. Okay, now let's check another question. The next question: if I have 60 meters from the distribution board to the final socket, does this work? Okay, I understand. If I understand well, you mean 60 meters from the distribution board. You have installed the SPD, and then my computer or end device is 60 meters away from this distribution board. If my understanding is right, then your computer is not protected. You need to install again another SPD nearby. Next, what about the DC SPD? I think we spoke about it already. And kindly brief once again the mechanical locking system available in the Type 2 photovoltaic SPD. Yes. So for the photovoltaic SPDs, we have a locking function, as you must have seen, those red locks. Those are there in case of short circuit currents. In the DC world, they bring with them enough impact and enough energy. So it's just not electrical energy, but also mechanical. So we have seen on the market that with the DC short circuits, those cartridges which are inserted inside the SPD can blow out. So those mechanical locks are there to protect those cartridges, and they help them keep them in place. Okay. I hope I have answered all the questions. Are there any more questions? I would again wait for a minute. Okay, I don't see any other question popping up. Therefore, I would like to thank you very much in this case. And later on, in case you think you have any doubts or any questions, please reach out to the local Hager contact in your vicinity, and they will help you out with this. Thank you very much. Bye-bye. Have a nice day.